Welcome to an Algebra 1 semester review for the second semester. We are going to start here with some absolute value equations. So absolute value bars, most of us will remember pretty easily, mean to take what's inside and make it positive. So if you have the absolute value of a -5, you switch it to a +5. But also, if you have the absolute value of a +5, that's also +5. So when you have an equation that involves an absolute value, what you have to do is you have to consider that with whatever's inside the absolute value could be either a positive answer or a negative answer. And so what we do to make this work when we're solving is we say, well, what if we take this -8 plus p and think about it being a +18? Or what if instead it was negative? If what is inside here is negative, we could just move the negative over to the other side. So we could consider the case where -8 plus p equals -18. And so if we solve these two equations, this will give us the two answers that would work for this situation. So we're saying there's got to be a number I can put here that will give me +18, I absolute value, and get 18. And then there's got to be another answer that would give me a -18, and then when I absolute value that, it would also give me +18. So this is a way that we can do that. We can solve both of these and get our answers. So on both of them, our steps are actually the same. It's just that because the number on the right side is different, we get two different numbers. 18 plus 8 is 26, and when I add 8 to -18, I get -10. So this question has two answers, kind of like parabolas, which if you are doing a second semester of Algebra 1, you've probably talked about. So these are our two answers, 26 and -10. So the same idea is going to happen here on number 2. -6x plus 10 could equal a +28, or it could equal a -28, because whatever x is, when we work this out inside, we'd get 28, absolute value, and get 28. Or we could work it all out, get -28, and then absolute value it, and it would still equal 28. So let's set this up as two different equations, one with a +28 and one with a -28. So we want to, on both of these, actually do the same steps. Again, the number on the right being slightly different will give us two different answers. So here I want to subtract 10 and get -6x equals 18, and then I want to divide both sides by -6. So x equals -3, that's my first answer. And then I want to do the same thing here, so I subtract 10, but this time I get a -38. So I divide both sides by -6 and get x equals, well, the negatives will cancel out because a negative divided by a negative is a positive. 6 doesn't go into 38, but they are both divisible by 2, so I'm going to write this answer as 19/3. You can change that to a mixed number if you want to, although for most, I would assume most Algebra 1 teachers are okay with leaving as a mixed number. I didn't like how that one looked. So 19/3 and -3 are our answers on number 2. Now let's look at 3 and 4, which are solving the inequalities with absolute values. So a similar thing happens here, that we want to consider the case that 5r could have something to do with 30 and 5r could have something to do with -30. But because we want this thing inside our absolute value to be greater than or equal to +30, there's something else that happens when we do the negative version. So if you want to think of it kind of how I wrote this first one up here, if I think, well, I could have +5r is greater than or equal to 30, or we could think of the case where we have, sorry, that's not looking the way I want it to, or we could have a case where -5r is greater than or equal to 30, right? Because what's happening inside of our absolute value could end up being positive or it could end up being negative. Well, when we do this step here to move the negative over, what's going to happen is it's going to make it flip directions. so that that would make this be r is less than or equal to negative 6. And so there's a trick we can do with this where we just always write it twice, one with a positive and one with a negative. And on the negative version, we just always flip the inequality around automatically. And that's why that's happening here, is because we've taken that negative and we've divided by negative. And with inequalities, when you divide by a negative, you have to flip the inequality symbol around. Now to graph this, these are equal to, so we need to put a closed filled in circle on negative 6 and 6. And then it says it's greater than or equal to 6. Inequalities, if your variable is on the left, are like arrows. So we want to shade to the right of 6, which is this way. And then this one is saying, hey, shade to the left of negative 6. These should point either both out away from each other or both in toward each other. And there's actually a cool trick where all of them that are greater than, if your absolute value is by itself, if it's greater than, it's an or, because it's great or then, and ors point out. I don't know why I tried to spell out with two U's. That's cool. So greater than, you shade out. If it starts off as a less than, now this is a lamer, even lamer than the great or. We'd say less than is less than, which is an and, so it actually shades toward each other. Now you can always just trust your inequalities at the end if you're making sure to flip the second inequality, the one that you make negative. So here, x over 8 has to be less than 2, but also x over 8 has to be greater than negative 2. So instead of worrying about writing the minus on the left side and then having to think about what to do, you can just always on the second one make the right side negative and flip the inequality. It's whichever one you feel like would be easier for you. So to get an 8 off the bottom, I need to times by 8. So x is less than 16. And this 8 I need to times by 8. And x is greater than negative 16. I did not mean to write 8 there. X is greater than negative 16. So at 16 we need an open circle, and at negative 16 we need an open circle. And we're pointing to the left from positive 16 and to the right from negative 16. So this way from 16, this way from negative 16. So these need to be shaded in between. Some beautiful shading. Really, it's just, you want to make sure that whoever is paying attention to this can tell which direction you shaded. So I think it's pretty obvious I shaded in the middle, which is what happens with an and. Also, if you are wanting to get technical with how we should write our answer here for inequality, there should be an or here since they're pointed out. Our answer is that r is greater than or equal to 6, or r is less than or equal to negative 6. And on this one we should have an and, because x is less than 16 and x is greater than negative 16. Another way to write ands is to put them in order from least to greatest. So the negative 16 would go first and 16 would go last, and you'd put the x in the middle with two less than to show that x is between negative 16 and 16. I'm not super picky about writing it like this versus writing it like this, but you should check with your teacher to see how picky they are. Let's look at some exponent rules. So the deal with exponents is we are being told how many of a certain variable or number there are. And that works differently than the number in front, the coefficient. And so whenever we see an expression like this, these regular numbers, those all need to go together. And they go together in a normal way. And then the x's need to go together. And we either need to know the exponent rules, or we need to think about what it's saying. X cubed is saying you have x times x times x. We've got 2x to the first. So how many x's do we have here? We have 5 of them. The exponent rules say add your exponents when you're multiplying x's together, and that tells you how many x's you should have. Then we do need to do 4 times 4 times 3, So 12 times 4 is 48. So that would be our answer. That is the multiplication property of exponents that lets us do that. When we have something inside parentheses and it's got a power on the outside, the important thing to note is that it affects both things, that this 4 and the m to the 4th, they are connected by multiplication, but they don't share exponents unless you have parentheses like this. So the parentheses tells us, hey, do 4 squared and then also do m to the 4th squared. 4 squared is 4 times 4, which is 16, and m to the 4th squared is like having m to the 4th 2 times, which is like having m 4 times and then m 4 more times, which is m to the 8th. So the property we're supposed to be remembering here is, hey, you can multiply these together, 2 times 4, and get 8. We don't do 4 squared and get 16 for the exponent, because that's not what it's saying. It's saying you have m to the 4th twice. How many m's does that make? It makes 8. These next two are the quotient property of exponents, and so that has to do with the idea that if you have a certain number on top and a certain number on bottom, we can cancel out what they have in common. So that set of n's can cancel and that set of n's can cancel. So what do I have left? I have n on top. The 3 and the 4 don't have anything about them that can cancel, so we'd leave them alone. So 3n over 4 is our best answer. The property says subtract your exponents, and that's what you should get for your n on top. So 3 minus 2 is 1, and that tells us to put n to the first on top. Now the thing with the subtraction rule is if you subtract them top to bottom, 1 minus 3 here gives you negative 2. And the thing is, we don't like to get negative exponents whenever we're mathematicians. We like for our exponents to be positive. So we would actually take this and move it down to the bottom, so that would give us 1 over 2a squared. Couple things here. This 2 has its own exponent of 1, and nothing in this problem ever told us to take the 2 off of the bottom. This essentially is a 1/2, and it should have remained a 1/2 the whole time. The other thing is, this is a case where maybe it would have been easier to just write it out and think about canceling. Look, we have 2 a's left. Those a's should remain on bottom because more a's were on the bottom. So I guess think of it like a Red Rover game. Nope, that's not a good example. But my point was going to be like which of these sides wins, the top or the bottom? It's the bottom because it has more things. If we're playing a game where having more things is what matters. So we get 1 over 2a squared. We wouldn't put the a squared on top. We wouldn't put the 2 on top. Now this last one on this section has a negative exponent, and so that makes us ask, okay, what do we do? But there's also another thing happening where we could combine these two exponents by adding them together. So there are two main ways to go about this. Both of them involve us doing the 3 times the 3 and getting 9. One of the ways means leave the p cubed on top, but maybe write it out. Take this p to the negative first and make it positive on bottom, and then look at how a set of p's cancels. So this is 9p squared. That's one way of going about it. The other way is to say, oh, I can add these exponents together using my exponent rules. 3 plus negative 2, no, 3 plus negative 1 is 2. Still do the 3 times 3 to get 9, and so that's the other way to get 9p squared. Doesn't matter which way you do it. You can either move down to the bottom and then figure out what cancels or subtract, or you can add the exponents together and leave them on top. Both of those are totally cool options. 10 and 11, we are simplifying radicals, and one of the best ways of simplifying radicals is to make a factor tree. 128 is kind of a big number. I know 2 goes into it 64 times, and 64 can split into 8 and 8 or lots of other things. We're going to end up with a whole lot of 2's here. When you make a factor tree, what you're looking for is pairs of numbers. So here's a pair of 2's, Here's a pair of 2's. Here's a pair of 2's. And we have a 2 left over right here. So when you're simplifying radicals, if there's a pair, that makes that number get a representative outside. So each of these pairs of 2's puts a 2 on the outside. There are 3 pairs of 2's, so I have 3 2's on the outside, but this 2 that's left over has to stay inside. On the outside, 2 times 2 times 2 is 8, so our answer to this is 8 square roots of 2. 75 is going to end up being a little easier than that, I think. 5 goes into it 15 times, and 15 splits to 3 and 5. So we've got a pair of 5's, which puts a 5 on the outside, and a 3 left over to go on the inside. When we're doing this, we're only looking at the prime numbers of our factor tree, and the reason that having a pair of 5's puts a 5 on the outside is we're essentially saying, what is the square root of that pair of 5's? Which is asking, what is the square root of 25? We know the square root of 25 is 5. That's why we're able to take it and put it on the outside. So 5 square roots of 3 is our answer. The slope of a line parallel to the given line. So slope in the equation of a line is the m. So here's m. Here is m in this equation they gave us. So what we need to know is, how do the slopes of parallel lines relate to each other? If these two lines are parallel, and we're thinking about rise over run, these would have the same rise over run. That's what makes them not meet. And so if the slope of this line is negative 5/3, and we want to have a slope that's parallel to negative 5/3, we better pick negative 5/3. Anything else we pick will make our line either go up too fast or up too slow so that they meet one direction or the other. Perpendicular lines are different though, because perpendicular lines are referring to lines that meet at a right angle, and so what their slopes need to have happen is basically the exact opposite. So if this slope is 3/1, then we want to change it so that the rise over the run is flipped. So we want to flip it, but we also want to change it from being a positive slope to a negative slope. And so the slope of the line perpendicular to 3 is negative 1/3. So you just take whatever the slope they gave you is, and you make it the opposite reciprocal. So opposite meaning change the sign, and reciprocal meaning flip it over. Alright, now we start talking about polynomials, and we pretty much talk about polynomials until the end of the review. Like, we start talking about specific polynomials called quadratic polynomials at some point, but they're all polynomials from here on out, technically speaking. We are going to name each of these polynomials by degree and by number of terms. Now, the number of terms is the monomial, binomial, trinomial, polynomial. And that, I think, is the easier part of this, because counting terms means counting how many things are there. This is a thing, this is a thing, this is a thing. And the prefixes of our words are things that are relatively common in the English language, so that it's not hard to know which of them is 1, which is 2, and which is 3. Just think of bicycles, tricycles, and unicycles. Oh wait, monocycles. Monotone. Always think of monotone. So think about that person you know that only has one tone, and that helps you remember the word monomial. The other part though is the degree. Degree has words that are familiar to math people, but maybe not always familiar in other ways. Constant refers to a degree of 0. That's when there isn't an x at all. A degree of 1 is called linear. A degree of 2 is quadratic. 3 is cubic. 4 is quartic. 5 is quintic. In my opinion, the toughest part of this is remembering quadratic and quartic, because both of those prefixes have to do with 4. Quar, like quarters. Quad, like well, there's a set of drums that there's 4 of them and they're called quads, and I feel like that's probably short for something. But those prefixes both have to do with 4. So it would be my hope that if you're reviewing for Algebra 1, you've been hearing the word quadratic a lot, like quadratic equations, quadratic formula, and so it's my hope that this stands out to you as being a degree of 2, because to use the quadratic formula, it has to have an x squared. Otherwise, it's just something that you have to memorize. So as we're looking at 14, we've got n cubed, and so this is a cubic, and then there are 2 terms, 1, 2, so it's a cubic binomial, A. 15, there is 1 term, so it's a monomial, and there are no x's, so it'd be like there's an x to the 0, so 0 degree, which is constant. And the other thing is the word constant in math usually means something without a variable, like is talking about just like a regular number is what we mean by constant. All right, we're going to rewrite this polynomial in standard form. So standard form is where you take the highest degree, the highest exponent, and you write it first. So we'd write negative 10b cubed first, and then you make it go down in descending order, like you count down. So next we'd want to put the squared, and then we'd want to put the b to the first at the end, which I did not need to put the b to the first there. I don't know why I did. So this would be our polynomial in standard form. Okay. All right, now let's do some adding and subtracting. When we're adding and subtracting with polynomials, you'll typically see a couple sets of parentheses, and you're looking at the sign that's in between. Maybe the instructions also tell you like this: simplify the sum, which means addition, simplify the difference, which means subtraction. But in either case, they usually have 2 different polynomials they're trying to draw your attention to, and inside the parentheses there's probably not any like terms. What you're trying to do is match up like terms from the first parentheses with the second parentheses. So for instance, 4x squared and 3x squared are both x squared, so we can add them together. You're not allowed to add together an x squared and an x cubed, or an x squared and an x. They have to have the same letter and the same exponent. So 4x squared plus 3x squared equals 7x squared. Then we would do negative x and negative 3x, which gives us negative 4x. And then negative x cubed and 5x cubed gives us 4x cubed. If you wanted to write this in standard form, it wouldn't be a bad idea. 4x cubed would come first, and then the x squared, and then the x. That is something that you can do. It doesn't tell us in the instructions to write it in standard form, so it kind of depends on how picky your teacher is about these things, as to whether or not you want to go through that extra effort. What I like to do is I like to actually just start with the biggest exponent first, to help me keep track that I've done everything. I also like to do this thing where I underline with different numbers of lines, or sometimes I will mark them out after I add them together to make sure that I don't leave anything out. For instance, here on 18, one strategy I like to use is starting with the biggest exponent. So this a to the 4th, I'm going to start with it, and there's only a single a to the 4th, so it doesn't change. Oh, but let's talk about what's different about subtracting. Subtracting, we need to think of each of these as the opposite sign. If I subtract 8a squared, what I can do is I can instead add a negative. If I subtract negative 8a cubed, that's like adding 8a cubed. If I subtract negative 7a, subtracting a negative is the same as adding. So now what we can do, because we distributed that, is we can just say, all right, this is now adding like terms again, which I personally am a fan of adding like terms. So we had this a to the 4th that didn't have anything to go with it, and we have this a cubed that doesn't have anything to go with it, so we'll leave that as plus 8a cubed. And then we'll look for things that are in common, like our a squareds are in common. 4a squared minus 8a squared, because we had to change the sign, is negative 4a squared. And then 2a and 7a add together to get 9a. Because remember, we were saying 2a minus negative 7a, which is 2a plus 7a, which is 9a. And that's the thing that is pretty tricky, that lots of people forget to. They either like only partially distribute it or don't even distribute it at all. And you have to distribute that negative, or that's the easiest way to do it, is to distribute that negative. Let's multiply. So again, we have parentheses. There's nothing in between the 5x and the parentheses, which is how in math we say multiplication, is that sometimes we'll put a dot, but also just putting nothing means multiplying. And when we multiply this, we want to use the good old distributive property. And so what that means is take 5x and times each of these things by 5x. 5x times x squared is 5x cubed. 5x times x is 5x squared. And 5x times negative 2 is negative 10x. I kind of feel like I rushed through that a little bit. When you're doing this, you multiply the regular numbers together, which neither of these had a regular number, so it just keeps the 5. When we do x times x squared, that's like what we did earlier where we said, okay, a single x times x squared, which is x times x, makes 3 x's. So adding the exponents together, or just thinking about how many you have, will help you adjust the exponents accordingly. So that's my answer. When it comes to a binomial times a binomial, or a binomial times something even bigger than a binomial, like a trinomial, what you would do is either use the acronym FOIL, or distributed properly does still work. You just have to be careful, because what you want to do is 2p times 8p, which is what the F stands for first. So 2p times 8p is 16p squared. And then you want to also do 2p times negative 4, which those two terms are the outer terms. If you think this is the outside and this is the inside, the ones closer to each other are inside. So 2p times negative 4 is negative 8p. And then you want to do the inner terms, which is the 5 times the 8p. If you're thinking of the distributive property, we essentially have distributed the 2p and now we're distributing the 5. So 5 times 8p is 40p. And then 5 times negative 4 is negative 20. Typically what happens with FOIL, not every time, but a lot of the time, there's middle terms that are like terms that we need to add together. So we have to finish this by saying, what is negative 8p plus 40p, which is negative 32p. And so we will just, not negative, plus positive 32p. We'll just keep that in the middle so that it is still like terms, and that's our answer. Okay, 21 starts our descent into everything quadratic. So we start here with graphing quadratic functions. Quadratic functions are parabolas when you graph them. That's a special word we use for quadratic functions. So a parabola is a U-shaped graph, and parabolas in general, if you're looking at their shape, they have a vertex, and then if it's the parabola that we call the parent graph, y equals x squared, then to get to the next points, you think of squares. So we start here at our vertex, and then we would go up 1 and out 1, because 1 squared is 1. And then to get to the next points from our vertex, we would go up 4. So 1, 2, 3, 4, and then out 2. Or I guess I would go out 2 here. So here's 1, here's 2, here's my next point. 1, 2. That kind of looks bad, but that is the shape of our parabola. And everything we do to parabolas, all the other parabolas in the world are some sort of transformation of this. So we can shift this left and right or up and down. We can make it go up faster. We can make it go up slower so that it looks narrower or looks wider, depending on how fast it's going up or how slow it's going up. We can also make it open down instead of opening up. And all of those things we can see in the equation. So it depends on what form our equation is in. This is in vertex form. And this is in standard form. So vertex form is the easier form to graph from, because what we need to graph is first and foremost the vertex. So the vertex is staring us in the face in vertex form is these two numbers, the number that's being added inside or subtracted inside, and the number that's being added or subtracted outside. If either of those numbers are missing, then they are zeros, like in x squared, where you don't have either of those numbers. That's why the vertex starts at 0, 0. So what we have to do, though, is we have to take what's inside our parentheses and use the super secret opposite society. The super secret opposite society says that anything inside parentheses in math does the opposite of what we think it should. So it's affecting x because it's inside here with x, and we are adding 4, which should make you think right 4, because that's the positive direction for x, but the super secret opposite society tells us, no, it's actually the opposite, and is left 4. What that means is that our vertex has an x value of -4. This number on the outside is telling us our shift up or down, and so a +3 means it's shifting up 3. It's not inside the parentheses, so it doesn't get to be part of the super secret opposite society. So our vertex from vertex form is the number inside parentheses changed, and the number outside of the parentheses at the end not changed. So we'd graph -4, 3. Notice on my graph here, kind of annoyingly, each of these little lines is a half, and so you have to actually go 2 boxes for each unit. So the other thing we need to know about is whether this is going up at a normal speed or if it's being reflected across the x-axis so that it opens down, and that is told to us by the number in front of the parentheses that's being multiplied. A 1/2, a positive 1/2, means that it's opening up, and that's going up half as fast as what we said over here our pattern was, which was up 1, out 1, up 4, out 2. So instead of going up 1 and out 1, I only want to go up half as far, but I still want to go out a whole unit. So I'm going to go out a whole unit, but only go up half as far as I normally would. And then instead of going up 4 and out 2, I need to go up half as much. So I'm going to go up 2, but still the same amount out. So out 2. Here is my parabola. This parabola is wider than the parabola I would have gotten if I'd graphed just normal x squared without this half. It's also moved to the left and up because normally our parabola would have been down here at 0, 0, 1, 1, and -1, -1, +1. 22 is in the standard form, so we've got an added step that we have to do. We have to figure out what the vertex is. There's a cool formula that tells us that, (b/2a). And if you're at the end of Algebra 1, then you've seen the quadratic formula, and so just as a cool thing that's happening, the quadratic formula has the vertex formula in it. Where does it have it? It has it right here. And if you have already gone through Algebra 1, you know that this part, the part under the square root, is a different formula. And so I've always thought it was kind of cool that the quadratic formula, which solves all of the quadratic equations you could ever want to, also has 2 other formulas inside it that tell us other important information about quadratic equations. Alright, so we label this A, B, and C, and again, if you've done quadratic formula, that's familiar. We say, let me plug these in, so -4 over 2 times A, which is -2. Having 3 negatives here makes our answer negative, and 4 over 2 times 2, which is also 4, gives us 1. So that tells us the x value of our vertex. To find the y value, we have to plug -1 in where our x's are, which can be a little tricky. We want to do -1 squared, which is 1. So negative 2 times 1 is what we'll do in a second. Negative 4 times negative 1 we can go ahead and do. That's plus 4. Negative 2 times 1 is just regular negative 2. Negative 2 plus 4 minus 6. That would be 2 minus 6, which is negative 4. So our vertex is negative 1, negative 4. Now what's cool about standard form is the same thing we did here where we looked at the first number to tell whether it was opening up or down. It was opening up because it was positive, and whether it was going up faster or slower or the normal speed. We can tell all that from what a is, the number in front of x squared. The negative means this is opening down. The 2 means it's opening down, and so the negative means it's opening down. The 2 means it's going down twice as fast. So instead of going down 1, out 1, we need to go down 2 and out 2. And instead of going down 4, we need to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. But still out 2. What we're doing when we do this is this is called a vertical stretch. On 21, it's called a vertical shrink or compression. And so we're only doing these things vertically. We're not affecting the horizontal, which is why I still went out 1 instead of, and out 2 instead of affecting that as well. So there is another way that you can do this, by the way, on both of these. You still start off finding the vertex the same way, but, well, I guess you don't have to find the vertex. You can always, on these types of problems where you're graphing, make a table of values. If you can remember how to find the vertex, that's helpful because it gives you a starting place that then you'd pick things that are on either side of your vertex instead of guessing like 0 and 1 and 2 and getting unhelpful numbers that are too big to put on a graph. So if you are ever stuck trying to graph something, this is always an option that you can use a table of values. And what you would do is you would plug in these numbers to this equation and work out what the y values are and then use that to graph. Alright, 23 and 24, we want to identify the vertex, direction of opening, and the axis of symmetry of the following parabolas. So we want to use the fact that they're in vertex form or standard form to help us get the vertex. We want to look at what's in the front to decide the direction of opening. The axis of symmetry, what that's referring to here, is that if you look at a parabola, it is mirrored on either side of the vertex. So this line I just drew would be the axis of symmetry for this, because you can think of it like a mirror, that these points are the same distance away from the line, these points are the same distance away from the line. And so really what you can do when you're graphing this also, by the way, is if we could figure out what these points are, for instance, you can just mirror them on the other side, and you don't actually have to plug them in if that's the method you're going with. This red line I drew is the line x equals negative 4, because vertical lines are x equals a number, and the number it's going through is negative 4. That happens to be the vertex here, or the x value of the vertex. So what we can do on 23 and 24, which you notice they don't have a graph provided, so we can find out all this information from these equations. So for vertex form, to find the vertex, you look at these two numbers, you change what's inside, and you leave alone what's outside. So our vertex here is 2, negative 1. The direction of opening is whether or not this is positive or negative, and since it's a positive 4, it opens up. And then the axis of symmetry is the x value of the vertex, but it's an equation of a line, so we put x equals 2, because that refers to a vertical line that is going through 2, that all of the points on this line are 2, something. So this would be our answer. 24, it is not in vertex form, so we're going to have to use our fancy formula, negative b over 2a. So that would be negative 8 over 2 times this negative x squared would be a negative 1. 2 negatives make a positive, so we're doing 8 divided by 2, which is 4. We're going to take that 4 and plug it in. Now, this is a tricky thing. tricky, tricky, tricky. When you plug a 4 into this x, your order of operations here say square and then make negative. Because what a negative x squared really means is that you have negative 1 times x squared. PEMDAS says do the exponent before this multiplication. So as much as you might want to say negative 4 squared is positive 16, it is not. And if you type that into the calculator, negative 4 squared, it will tell you that that is negative 16. In order for you to get it to say that it's positive 16, you have to put the negative 4 in parentheses to show that you actually want to square the whole number. Now, if I was plugging in a negative 4 instead of a positive 4, I would in fact, it's kind of complicated and maybe not quite on subject here. If this is what we were trying to plug in, we would square this negative 4 and get positive 16, but then we would still make it negative. So there's an interaction happening here that's kind of tricky that you have to be really careful about how you think of it. You want to square first and then make that answer negative. 8 times 4 is 32, and then minus 10. So 16 minus 10 is 6. So the y value is 6. The x value was 4. So 4 comma 6. The negative means that it opens down. The negative in front of the x squared, that is. And our axis of symmetry is x equals 4. So 25 is a question that looks tricky, but is actually super easy. One of the things we can do with graphs is we can talk about solutions to quadratic equations by graphing. But we already graphed equations, so I thought, you know, what if I just ask you to solve something and I already have, like, I've already given you the graph. So it says the following graph is of the function y equals blah, blah, blah. According to the graph, what are the solutions to this equation that goes with that but equals 0? What that's asking you is, where does it go through the x-axis? Because that is where y equals 0, is right here along the x-axis. So there are two answers to this because it goes through at two places. X equals negative 6 and x equals 2. Voila, that's our answer. So if I didn't give you the graph and asked you to solve it, that would be a more difficult problem because you'd have to graph it first. But you'd still do the same thing. You'd say, okay, where is it going through the x-axis? 26 is tricky if you're having trouble with graphing because of this idea of transformations. If you're using a table of values, instead of thinking about the transformations to graph, then you'd want to, I guess, try to come up with this separately. The idea that this has an effect, this has an effect, and this has an effect. There's actually 4 different types of transformations that can be happening. There can be a reflection. We would either say over or across the x-axis. So that happens when there's a negative in front. That's not happening here, but that is a thing that can happen. We can have a vertical stretch or compression. And so that would be the number in front here, this 3. Because this number is bigger than 1, it is stretching. So we'd say that there is a vertical stretch by 3. If it was a number that was smaller than 1, like a third or a half or something like that, it would be a vertical compression instead. The number on the inside here, this negative 1, remember super secret opposite society, we are shifting right 1. And then outside this negative 9, we are shifting down 9. It is important, at least for me, it is important that you say what you're stretching by, what you're shifting by. And yeah, that's how we do it. You could try, if you are having trouble with transformations, you could try try drawing your own graph, because you would see that you've moved, if you can think about what y equals x squared looks like compared to this, you can see that you've moved it right and you've moved it down, and you might also be able to tell that that the graph is going up faster, so it's a vertical stretch. But it's really, in my opinion, easiest just to look at what is happening with your equation. And now we're on to factoring. So the issue with factoring is it's all a bunch of different ways to split something up into two things or more that multiply to get what you start with. It's like the opposite of the distributive property or FOIL, and it can be just hard to remember which thing is which. So our instructions here have some clues for us. We're going to factor the greatest common factor out. So look at these three terms and figure out what can you divide all three of them by. What's the biggest thing that you can divide them all by? I'm seeing a 3, not a 9 because of this, and an x. They all have an x. What we're going to do is divide each of these by 3x. But because we want to write this out as a basically reverse distributive property, the 3x is going to go in front of a set of parentheses. We're dividing each of these by 3x, and so then we'll write what happens when we divide each of them by 3x inside of our parentheses. 27x divided by 3x, 27 divided by 3 gives you 9, and the x's cancel. Another way of thinking of it is to say 3x times what gives you 27x. So if that's easier, 3x times what gives you 18x squared, that would be 6x. And 3x times what gives you 15x cubed, it'd be 5x squared. So what's cool about factoring is that usually algebra students are pretty good at distributive property. If you do the distributive property, you should get this, what you started with. So that's a cool trick to try. 28 and 29, it says factor each completely. I've given a hint here. Your goal is to split the trinomial into two parentheses. So 2 parentheses, that's our goal. Now, the way we do this is we are reverse foiling. If you think about what happened earlier on our FOIL problem, FOIL gave us 4 terms, and then our outer and inner terms ended up being like terms that added together. Our first thing came from this times this, and that gave us this first thing right here. So what times what can give us r squared? Well, the most likely option seems to be r times r, so let's go with that. The last term came from this times this, and so that's also what got us this 36 if we're reverse distributive propertying this. So if we have 36 and we're trying to think of two numbers that multiply to get 36, there are a lot of options. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So how do we decide which one of these? Also, they could both be negative and still multiplying at positive 36. So the key to knowing which set to use is this right here. And now that looks like a weird smiley face. So I hope you can unsee that at some point in your life. We look at the outer and inner terms here, and we say, I need these numbers to add to get 13, and they would have an r with them if we do r times this and r times this. So which of these pairs adds to get 13? Let's see, 37, 20, 15, 13, and 12. So we want to put plus 4 and plus 9. And so let's check and see if this worked. R times r is r squared. R times 9 is 9r. 4 times r is 4r. Those add together to get 13r. And 4 times 9 is 36. So here's our answer. R plus 4 times r plus 9. So this is a thing that really comes down to remembering that it's thinking of two numbers that multiplies to get the last number, and then that picking the pair that also adds to get the middle number. So we'd put n and n. We'd think what multiplies to get negative 35, which I like to just first think about pairs in general and then pick out a negative. We only have two options here, which is nice. And 1 and 35, no matter how you subtract them, you can't get 2. So let's think. Do I want to do 5 minus 7, or do I want to do 7 minus 5 to get a positive 2? Well, I want to do 7 minus 5. So that tells me that I want the 7 to be positive and the 5 to be negative. So here is my answer. On 30, it says factor completely, and it gives a hint again. You will need to use guess and check, or the box method, to factor the expression into two parentheses. There's also other ways other than the box method. There's a method called split the middle term, and there's a method called slide and divide. And so there's lots of options there. The point of this was basically to identify like kind of which of the things that we've learned you should be trying to do. The box method starts with a big box that you make into 4 smaller boxes, and if you've done Punnett squares in science class, then this should seem kind of familiar to a Punnett square. To fill in the box, we put the 2n squared in the top left, and we put the 14 in the bottom right. And then the 11n is going to go in these two diagonals, but they're going to go in those diagonals. Like we have to split them up so that they add to get 11n. And the way we decide how to split them up is, this is what's different from what we did earlier. We do need to do 2 times 14, which is 28. And we're going to think of pairs to get 28 that add to get this 11. Because the interaction happening here for what we would do to FOIL makes this more complicated than what we had to do before. And the difference is that there is something in front of n squared. That's why we're having to use a more complicated method. So to add to get 11, I would use 4 and 7. So 4n and 7n. And then this is going to help us figure out what's in our parentheses, because we're going to look at what's in common on the top row, what's in common on the bottom row, what's in common on the left, and what's in common on the right. So 2n squared and 4n have 2n in common. 7n and 14 have 7 in common. Looking here and here, they only have an n in common. Here and here, they have 2 in common. What should happen if we've done this right, and this should be like a Punnett square thing, is that this times this should give you this, and then we could like keep going. The 2n times the 2, I guess I'll do the 2n times the 2 should give us the 4n. The 7 times the n should give us 7n, and the 7 times the 2 should give us 14. So it's like we did like a reverse Punnett square sort of thing. And so what that means is that one of our parentheses should have 2n plus 7, and the other should have n plus 2. And that's our answer. You could actually use this box thing as a way of multiplying out binomials if you'd like to. One of the tricky things on this is when negatives come in, and that didn't happen on here. If you did a box method and both of the diagonals are negative, you would want to make both of these numbers negative. And that's an important thing to know. That's not obvious just from the way the method works. I'm going to take off those negatives now. Our next type of factoring by grouping, is the one where we look at this group and we look at this group and we look at their greatest common factors. So the greatest common factor of the first group is 6x squared, which gives you 6x plus 5 when you factor that out. And then you look at what the second group has in common. They don't have anything in common really, other than that they're both negative. And so we could take out that negative by dividing by a -1, and that would give us a positive 6x and a positive 5, which is what we want to do, because the point of factoring by grouping is to get the same thing in a set of parentheses on each of these. So if we had decided not to take out a negative earlier, like, we would be stuck. We need to take that negative out. And so if these both have 6x plus 5, then we write down the 6x plus 5 that they have in common, and then we write down what's in front, which is the 6x squared and the minus 1, and that's going to go in our other parentheses. So our answer here is 6x plus 5 times 6x squared minus 1. On each of these where we've had like two parentheses, you can write the parentheses in either order. You just don't want to like mix the things up, like put this minus 1 with this regular 6x. That's not the same thing as what we have written right now. There are some special patterns you can use when you're factoring, and you don't have to use them. Even if it says to use special patterns, you don't have to use them. But the special patterns have to do with square roots. So the fact that both of these have square roots is important and is how we know we can use the special pattern. The fact that there are two terms with a minus in between tells us what our answer should look like. If there's square roots in two terms, we're going to put into two parentheses. One parentheses is going to have a plus, one is going to have a minus. And the things that we put in both of them have to do with what the square root of the first thing is and the square root of the second thing. So we're going to put 4m plus 5, and we're going to put 4m minus 5, and that is our answer. Now, if you wanted to do it without the special pattern, you'd essentially have to be thinking of this as having a 0m in the middle and using whatever method you want to come up with this, like the box method or guess and check, whatever your normal method is. That's what you'd have to use here to figure that out. On the next one that we have that has three terms, this is funny because with the special pattern, you do square root and square root here, and then you say, okay, the only thing I really care about from the middle is the negative. So we put one parentheses, we put a negative in the middle because it's negative 12a, and then we square root the outside one. So 3a and 2, this is our answer. And people will ask me repeatedly, even if I've literally just said the answer to somebody else that they were supposed to be listening to. They'll say, but where did the negative 12a go? Well, let's think about what happens when we do 3a minus 2 times 3a minus 2. 3a times 3a is 9a squared, and negative 2 times negative 2 is 4. But then when you do the 3a times negative 2, you get negative 6a, and then negative 2 times 3a, which is also negative 6a, you add those together and you get negative 12a. So it's not that the negative 12a went anywhere, it's just that because the middle term here came from adding this, the square root of this times the square root of this, adding that together twice, it just looks like it went away because we only had to write our parentheses once. But it didn't go away, it just wasn't necessary for us to use to get our answer. Alright, 34. Solve by factoring. And this is our first solving equation problem, and that's pretty much what we're doing for the rest of this now. We are solving the equation by factoring, so let's go ahead and factor this. So it doesn't give us a hint on how to factor. There are three terms. There's no square roots. I mean, I guess we could square root this, but we can't square root this. And there's not anything in front of x squared, so this is just regular factoring where we put x and x. We say, what multiplies to get negative 15 that adds to get negative 2? Well, my options are 1 and 15 and 3 times 5. 3 and 5 subtract to get 2, and we just have to figure out which of these two ways we want to do that subtraction. Since we want a negative 2, we need the 5 to be negative. So we're going to put plus 3, and we're going to put minus 5. Now, this is different than what we were doing before because it says solve and it says equal 0. So we need to go a step further and say, what value for x makes each of these parentheses 0? Because either 0 times this equals 0, or this times 0 equals 0. And so we're essentially trying to figure out what would make either of those situations happen. So what makes x plus 3 equal 0? Well, you could actually make an equation out of that and subtract the 3 over, or you can use the super secret opposite society to help you because they're in parentheses, so what we want is the opposite. Or you could just think in your head, what minus 5 gives me 0? which is another way that we can get plus the positive 5. So our two answers here are -3 and +5. Let's solve by taking square roots. So when it says taking square roots, that's supposed to be a hint, but sometimes people will take square roots too early. We want to wait until the m squared, or whatever letter squared, is by itself. So we want to essentially pretend the squared's not there and solve this for our variable, but then remember that it is there so that we can square root both sides. So I want to start by adding 8, just like I would in a normal equation, back in the good old days when things were simple, like last semester. So 262 plus 8 is 270. Then I want to divide by 6. 270 is a big number, so I bet 6 goes into it evenly. 6 goes into 27 4 times with 3 left over. So then that's 6 into 30, which is 5. So now that m squared is by itself, now I'm ready to square root both sides. But here's the thing. Whenever I square root in an equation, I have to remember to put a plus or minus, because there are two things that when you square them give you 45, and one of those things is positive and one of them is negative, because when you square a negative number, you do negative times negative, and that makes positive. So that's one of the tricky things to remember here, is that we have to put a plus or minus sign. Now the square root of 45 is not a perfect square, but if we use a factor tree, we'll see that it simplifies, because there is a pair of 3's and a 5 left over, so the square root of 45 is 3 square roots of 5. So there's our answer. We're going to do the same sort of thing on 36. I'm going to add 3 over. And then divide by 36. And at this point you might be thinking, well, this sounds terrible, because you can't divide 1 by 36, and you're right, you can't. But the bright side is that both of these have a square root, and so if I square root both sides, I get plus or minus. The square root of 1 is 1, and the square root of 36 is 6. So I get plus or minus 1 over 6, which overall isn't really that terrible of a number in my opinion. So you could also, if you do end up here deciding to take the square root on both sides where it says 36b squared equals 1, you can end up with the right answer. It's a lot harder over here with 6m squared equals 270 to get the right answer if you square root too early, which is why I recommend you wait till the very end to square root. But just know that if you noticed here that these were perfect squares and square rooted a little early, that's not the end of the world. 37. We are getting close to the end here. 37 says, solve the equation with the quadratic formula. I wrote that formula down earlier. I guess I can write it down again. There's a cool Pop Goes the Weasel song that you can use to remember this. And also, if you look at my channel, I did a rap version of it that can help you memorize it if you haven't already. So x equals -b, and here we're going to label a, b, and c. So x equals, or in this case I guess it's k is our variable, k equals -b. So I messed that up. I'm going to try again. Negative, and b is a positive 12, so that turns into -12. If you have b is negative already and you do -b, then that would switch it to positive. Then we do plus or minus b squared, so 12 squared, minus 4 times a times c, all over 2 times a, so 2 times 2. Now, in order to simplify this, we are going to do 12 squared, which is 144, and we're going to have to do -4 times 2, which is -8, times -19, which is 152, but it's positive. So we need to do 144 plus 152 underneath our square root, which ends up being 296, which is a rather large number, and that's kind of unfortunate. 2 times 2 on bottom is 4. I want to simplify square root of 296 if I can. I'm pretty confident it's not a perfect square, but it probably has a perfect square inside of it. So 148. 148 goes to 74. 74 goes to 37. And so that means that we're done. 37 is prime. So we have a pair of 2's. So we're going to put a 2 on the outside. But 2 and 37 don't have anything to pair up with, so they actually need to go back together and become 74. There's one more step that we can do. You look at the numbers not including the square root, these 3 numbers, and you have to have all 3 of them here. I cannot simplify this negative 12 and 4 here, because there would also have to be something in front of the square root in order to simplify. Now that I have something in front of the square root, I can divide them all by what they have in common, which is 2. That would make it 1 square root of 74, or you can just write square root of 74. This, I believe, is the answer. Alright, on 38, the discriminant is that other formula I mentioned that was in the square root. No, it is in the square root, but is in the quadratic formula. And so we just need to do b squared minus 4ac, and that tells us what the discriminant is. It says find the discriminant. So we want to figure out what is that number, and then we want to use that number to figure out the number and type of solutions. So let's label A, B, C. So we've got negative 4 squared. If you're typing this into the calculator, you need to put the negative 4 in parentheses to square it, or it's not going to do what you wanted it to. That's a positive 16. There are 3 negatives here, so we're going to minus. 4 times 2 times 2 is 8 times 2, which is 16. 16 minus 16 is 0. So the answer to the discriminant is 0. That tells us how many solutions there are, because when the discriminant is a positive number, then that means there's 2 real solutions. When it's a negative number, that means there's no real solutions. And when it's 0, which is the only other option between positive and negative, 0 means there's 1 real solution. So the fact that we got 0 means that there is 1 real solution. Okay, we have 2 more questions that are related to solving quadratic equations. You get to use whatever method you want, which I know means that some of us will just decide to use the quadratic formula, which is fine. But if you realize that some other way will get there faster, you should definitely use it. For instance, if we were missing the middle term on either of these, we would use square roots, and that would by far be the fastest method, and hopefully would be the method that we would be the least likely to screw up. Completing the square is not a great option. It lists it just because we did talk about completing the square, but if you're willing to use completing the square, you should just use quadratic formula instead. What we do want to look at on these is we want to make sure they're in standard form, but we also want to check to see if there's something that we can divide all of them by. For instance, no matter what method you choose, if you notice that you can divide all of these by 2, you will have an easier time. Even 0 divides by 2, which is why we're allowed to divide by that 2 and then ignore that it was ever there. Unlike in normal factoring, where we'd write the 2 in front. You can do that, but you don't have to. You can just get rid of it completely. Now, if you notice that you can multiply and get negative 42 with numbers that also add to get a positive 1, then your best bet here is to factor. Because 42 is 6 times 7. It's negative, so we can make one of those negative. So we'd do x plus 7 and x minus 6, which means that our answers are negative 7 and positive 6. Now, let's say that you didn't realize that, but hopefully you at the very least realized that you could get here by dividing everything by 2. Let's say you decided to use the quadratic formula. If we didn't divide by 2, we'd have bigger numbers, which just makes math harder. Under here we've got 1 plus 4 times 42, which is 168. So 1 plus 168, which is 169. That is a perfect square. So we'd get 13. And then when that happens, that that's a perfect square, you can find your two answers by saying, well, what's negative 1 plus 13 divided by 2? And what's negative 1 minus 13 divided by 2? And you should get, this one would be 6. Negative 1 plus 13 is 12, divided by 2 is 6. Negative 1 minus 13 is negative 14, divided by 2 is negative 7. So whichever way you do it, you should get the same answer, but you got to do it whichever way, I guess, is easier for you. On 40, you might look at this and say, well, there's a 5 in front, so I can't do normal factoring, and so you could try doing the box method. It might be worth it. That's where you say, and really to figure out if it's factorable, you don't even have to go very far. You just say, well, 5 times 3 is 15. Is there anything that multiplies to get 15 that adds to get 16? Which there is. 1 times 15 also adds to get 16. That's our clue that we can factor because we found something. And I would argue that we found it relatively easily. So I'd put 15x in one of these spots and 1x in the other. I'd look at what's in common on the top two, which is 5x. Nothing in common on bottom here, so we'd put 1. I'd look here on the left, they have an x in common, and here on the right, they have a 3. Remember, you can check by like trying to multiply this back out and trying to see if it gives you what's in the box. So my answer is 5x plus 1 and x plus 3. Now, when you're solving this, it's a little trickier with this 5x plus 1. The x plus 3 is still pretty easy. Either by thinking, oh, it has to be the opposite because of the super secret opposite society, or actually writing this out and subtracting it, we get x equals negative 3. This other one might seem trickier, but if we just say 5x plus 1 equals 0 and then solve, that means subtracting 1, which gives you 5x equals negative 1, then divide by 5. So you can't actually divide that by 5. X equals negative 1/5, and x equals negative 3. And we can get the same answer by doing the quadratic formula, although 16 squared, that's kind of a big number. 16 squared. 6 times 6 is 36. 256. 4 times 5 is 20, times 3 is 60, so 256 minus 60 is 196, which is a perfect square. The square root of 196 is 14. So we'd have negative 16 plus 14 over 10 and negative 16 minus 14 over 10. So negative 16 plus 14 is negative 2 over 10, which gives us the negative 1/5. And negative 16 minus 14 over 10, that's negative 30 over 10, which gives us the negative 3. So whichever way you choose to do it, whether you decide to try factoring or decide to do quadratic formula, you just gotta pay attention to the details there. That's the worst part of the quadratic formula by far. This has been a review of the second semester of Algebra 1. I hope that it went really well for you and that it helps you with your test and that everything in your life goes super, super well. If you don't mind terribly, I'd love it if you would like, comment, and subscribe, and maybe I'll see you in another video. Thanks!